Yes, good morning all. So in the last classes we have covered OSI model. Now in this class we are starting TCP/IP reference model. So transmission control protocol / internet protocol TCP/IP reference model. So in the last classes we have covered OSI, where it is having 7 layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer and application layer. So total 7 layers will be there. But in TCP/IP only 4 layers are there. Remaining 3 layers not present in the model. So as the diagram it will show you. So physical layer actually not there. It will be combined with the data link layer. So combinedly it will be a link layer. So network layer will be renamed as internet layer. Transport layer is as usual. Presentation layer and session layer not there. That is combined with the application layer. So in the TCP/IP model we are having 4 layers: link layer, internet layer, transport layer and application layer. So the summary of all the 7 layers in the OSI model is where the physical layer, which is transmitting the bits over a medium. It will provide both mechanical and electrical specifications, while in the data link layer we have to organize the bits into frames, and the data link layer provides hop to hop delivery. Network layer, which will move the packets from the source to destination, it will provide inter-networking, while in the transport layer it is mainly responsible for process to process delivery and error recovery. Session layer, which is mainly used to establish, manage and terminate the sessions. Presentation layer is for encrypting, compress the data, translation of the data, okay, and finally application layer is to allow and access to network resources. So all these 7 layers is the working conditions and working principle of all the 7 layers. While this diagram will show you what are the protocols which are used in every layer of TCP/IP model. I told you in the case of TCP/IP layer, data link layer and physical layer combinedly is one layer, which is link layer. So the protocols defined by the underlying layers, which is host to network layer. While the network layer is renamed as internet layer in the TCP/IP protocol, where internet protocol is one of the protocol, then internet control message protocol ICMP, which is used to send the messages. Internet group message protocol, which is used to send, if you want to send a group of messages, then ICMP protocol will be useful. ARP and RARP, address resolution protocol, reverse address resolution protocol. So if you want to resolve the address, you know the IP address, you want to find out the physical address. So address resolution, or reverse, you know the physical address, you want to find out the IP address, or you know the IP address or you want to find out the physical address. So ARP and RARP will be useful for both of these applications: address resolution protocol, reverse address resolution protocol. Then the next layer is a transport layer, where transmission control protocol TCP, user datagram protocol UDP, stream control transmission protocol SCTP. All the 3 protocols will be comes under transport layer. So TCP is a connection oriented protocol, while UDP is a datagram or connectionless protocol. So if you want to send a stream of messages, the stream can be controlled by using SCTP, stream control transmission protocol. Well, I already told you application layer, presentation layer and session layer comes under applications. The protocols are file transfer protocol FTP, then domain network system DNS, okay, telnet, SMTP simple mail transfer protocol, email, pop-up, telnet, okay, all these comes under application layer protocol. So while As I told you, the TCP/IP consists of 4 layers: physical layer, logical layer and specific layer. Okay. So there are 4 types of possible addresses are possible: physical address, logical address, port address and specific address. So while the physical layer and data link layer combinedly is one layer in the TCP/IP, where we will use the physical address. Okay. So physical address is 48-bit long. Then network layer or internet protocol, where we will use logical address or a network address, which is IP address is 32-bit long, version 4. IPv6 is 128-bit long. So transport layer, in the transport layer we will use port address for both all the TCP, UDP and SCTP. Finally, at the application layer we will use specific address like www.google.com. Okay, specifically we have to mention. So all these 4 addresses mostly we are using in the TCP/IP layer. So physical address will change from hop to hop, while the logical addresses usually remain the same. Now, up to now we have covered all the 2 layers like OSI model and TCP/IP model, while the next we are starting transmission media. So transmission media and physical layer. Okay, so if you want to transmit, I told you in the case of physical layer, data will be transmitted in the form of bits. Okay, so its underside physical layer will transmit the bits. Those bits will be transmitted through a transmission media, which is either a cable or we are transmitting in the air. At the receiving end, the receiver physical layer will receive those bits. These transmission media can be categorized into 2 categories, either guided transmission media or unguided transmission media, that is wired or wireless transmission media. So in the case of wired transmission media, again there are 3 subcategories: twisted pair cable, coaxial cable, fiber optic cable. In the case of unguided transmission media, a free space is the or wireless transmission media. First we are starting guided transmission media, where there is a possibility, that is a physical, through physical, either through cable. So there is several types of cables are available. Okay, so there is a conducting media should be there. So if you want to transmit, there should be a conducting media. If you want to transmit from one device to another, including twisted pair cable, coaxial fiber cable, optical fiber cable. Now first we are starting about twisted pair cable. So the name implies twisted, that is it consists of 2 wires which are placed in the form of twisted. So why they are not arranging in the parallel? Because if you arrange the 2 wires in the parallel, okay, so whenever you are transmitting those signals, so any extra noise will be added together, that will be doubled. But while you are transmitting through like the twisted manner, so if any noise is added at the receiving end, so as the twister which are arranged like a positive and negative, both will cancel each other, so the final noise will be 0. That is the advantage of using twisted pair cable. So in the case of twisted pair cable, the final noise will be 0 because one is positive and one is negative, so that they will cancel each other. As we are transmitting in the parallel, there is no possibility of cancelling each other. That is why mostly we are preparing or we are prefer twisted pair cable. So this is how the twisted pair cables are arranged in a separate insulating media, where it is called as UTP, like unshielded twisted pair cable. So within the insulating media there are 4 twisted pairs are there, that is total 8 wires will be there. So each pair is arranged like a twisted. So it is unshielded, we are not shielding it, that is the name, unshielded. So category 5, so the speed varies based on the category. See here, these are digital transmission media bit rates. So bit rates of digital transmission media we are using and observations. So in the olden days we will use telephone twisted pair cable. Mostly the data will be transmitted at bit rate in kbps only. Okay. Then Ethernet over twisted pair cable, that is the LAN wire is Ethernet, so which is 10 megabits per second, while same fast Ethernet over twisted pair cable 100 Mbps. Okay. Then ADSL or twisted pair cable or cable modem mostly 1.536 to 6144 Mbps. Then radio LAN 2 Mbps, digital radio 1.5 to 45 Mbps, optical fiber cable which is having mostly bitrate is very high. So mostly we will prefer optical fiber cable. So this is the difference between UTP and STP cables, that is twisted pair cables are categorized into two, unshielded or shielded. So if you are shielding, a metal shield will be there. So see in the diagram it will show you a metal black color metal shield will be there, on the top we are placing plastic cover. But in the unshielded twisted pair cable there is no metal shield, directly a plastic cover is placed inside the twisted pair cables. So what is the categories of this? So every category there is a difference between the speed only, data rate or Mbps will be there. So category 1 UTP, the data rate will be less than 0.1 Mbps. Category 2 UTP 2 Mbps. Then category 3, okay, 10 Mbps mostly used in the LANs, from category 3, 4 up to 7. So mostly we are using the LANs. Category 1 and 2 mostly we are using telephone lines. So category 5, 5E, 6, 7, you can see how the data rate will be changes, only the data rate will be changes. Okay. So category 7 we can call it as SSTP, shielded screen twisted pair cable. So each pair is individually wrapped in a helical metallic foil followed by a metallic foil shield in addition to the outside shield. The shield decreases the effect of crosstalk and increases the data rate. So that is the advantage of using SSTP. Extra we are using a helical metallic foil followed by a metallic foil to eliminate the effect of crosstalk and increase the data rate. So here this is the how the category 1 no performance criteria, category 2 rated to 1 MHz, category 3 corresponding to voice graded twisted pair cable up to 16 MHz, category 5 used for faster net more tightly twisted. Okay. So category 4 20 MHz. So category 4 used for token ring 10 base T, category 3 used for Ethernet 10 base T. So what is this 10 base T, 100 base T, we will see. Now see here 10 base T. So 10 represents 10 Mbps speed, where base represents baseband transmission over capital T represents twisted pair cable. That is a 10 Mbps baseband transmission signal we are transmitting over a twisted pair cable. Okay. So in the 10 base T, 2 category 3 cables and each cable is encoded, that is signals will be encoded by using Manchester encoding, and it can transmit up to 100 meters distance. This is how the UTP connector, so male and female RJ45 radius jack, 45 female cable and male cable, total 8 pins will be there. Okay. So 1 and 2 are 7 and 8, 3 and 6, 4 and 5, those are connected. Then the next category of data transmission is the coaxial cable, where it consists of two conductors, inner conductor and outer conductor. In between we are placing an insulator. Okay. So inner conductor is there, after that insulator, then outer conductor is a pink one which is shielded, then insulator will be there. Finally these two conductors are finally protected by using a outer plastic cover. So coaxial cables are again of two types, either 50 ohm cable baseband transmission or 75 ohm cable broadband transmission or single channel baseband. So coaxial cable has better noise immunity over twisted pair cable. For higher frequencies they will provide higher bandwidth than the twisted pair cable, but the cable is bulky. So 50 ohm cable is mostly exclusive for digital transmission, it will use Manchester encoding. Okay. So 10 base, for example you can see 10 base 5, so it is called as thick Ethernet, and 10 Mbps, 500 meters maximum segment length, 100 devices per segment. Similarly 10 base 2, which is called as thin Ethernet, so it is 5 mm thickness. So 10 Mbps, 185 meters maximum segment length, every segment 30 devices, easier to handle, uses T-shaped connectors. Then the next one is broadband coaxial fiber cable. So 50 ohm is a baseband transmission, directly we are transmitting the signal. But for a broadband signal mostly we are using modulation, a 75 ohm cable used for both analog and digital signals. LO signal up to 500 MHz is possible. So when the FDM, frequency division multiplexing is used, it is referred to as broadband. So for longer distances, transmission of analog signal amplifiers are needed every few kilometers. So these are the different categories of coaxial fiber cable. I told you two categories, 50 ohm and 75 ohm. Again in the 50 ohm two things are there, RG58 and RG11, thin Ethernet, thick Ethernet. RG59, a 75 ohm cable, is used for cable TV. Then the next category of data transmission is the optical fiber cable, where we already learned in the previous, like in the intermediate classes, where whenever light is false or light is transmitting from one media to another media, so at the edge of the two media there is a angle or there is a bending of the light ray will be applicable. So that is decided by the where the two media, where the first category is where the incident angle is less than the critical angle of reflection, where first medium is the more dense, second medium is the less dense. Okay. So second category is where critical angle is equal to I, then critical angle is greater than I is the third category. In the first category light will be slightly reflected, but for the second category, if I is equal to critical angle, it is transmitted over the media, while in the case of I greater than critical angle, so TIR, total internal reflection will be there, that is whatever the light we are transmitting, again it will come back to the total medium one only, total it will not transmit to any second media, totally it will be reflected, TIR. So that is we are using in the case of optical fiber cable. So total internal reflection we are using. So at the sender we are sending a light signal. So the optical fiber consists of two media, core and cladding. Between these two media, whenever we are transmitting a light, okay, so the light will be totally internally reflected, again it will touch back to the again cladding media, core media, so finally it will receiving at the receiving end. So the light, like in the case of optical fiber cable, light will be transmitted in either of two modes, single moded or multi-moded. Again in the multi-mode, step index and graded index, that is how the refractive index varies. If the refractive index varies like a step, that is step index, then if the refractive index varies like a graded, that is called as graded index. See that there are three categories: multi-mode step index, multi-mode graded index. In the single mode there is no step or graded index, only one thing is possible, that is whatever the light we are transmitting, it does not have any total internal reflection, totally it will reach. But in the case of multi-moded graded index, so it will be reflected slightly, but in the case of multi-mode step index, that is a basic thing where the total light will be reflected. So these are the different type of optical fiber cable, and core thickness, cladding thickness, what is the mode and type. Okay. So for example, see the type 50 by 128, 125, what is 50? Core thickness, cladding thickness is 125 micrometers, which is multi-mode graded index. First three are the multi-mode graded index, last thing is a single media. So this is how a optical fiber will look like. So glass or plastic core will be useful as a core. Similarly plastic buffer will be there, and to improve the strength we are using outer jacket will be there. So cladding also mostly we are using a glass. So these are the different connectors or optical fiber cable connectors which are we using while we are transmitting through optical fiber cable. Then the last one is a unguided transmission media, where without any physical media we are transmitting the signals, which is through air. So this type of transmission we can call it as wireless communication. So these are the electromagnetic spectrum for wireless communication, mostly 3 kHz to 900 terahertz. Okay, radio wave and microwave 3 kHz to 300 GHz, infrared waves 300 GHz to 400 terahertz. So 3 propagation methods are possible in the case of wireless communication: ground wave propagation below 2 MHz, skywave propagation 2 to 30 MHz. So above 30 MHz, line of sight propagation. So in the case of ground wave propagation below 2 MHz, we are placing the cables under the ground. So in the case of skywave propagation, where we are transmitting signals through antenna that will touch to the ionosphere, again it will come back to the receiving antenna. That is called as skywave propagation. But in the case of line of sight propagation, where we are placing 2 flashlights, these are communicated by using some line of sight mode. That is, they are arranged like this. That is, so whenever a transmitter is sending, the transmitting satellite is sending, so during the line of sight direction only we are placing the receiver, so that both will be able to communicate with each other and will receive the signals, which is mostly possible above 30 MHz. So these are the different bands and their applications. So very low frequency 3 to 30 kHz ground wave propagation, that is very low frequencies we are transmitting through ground wave propagation, mostly radio navigation, radio beacons. So medium frequency, high frequency and very high frequency we are using skywave propagation, where AM radio, VHV TV, FM radio, all these are skywave propagation, while the last 3 are the line of sight propagation, 300 MHz to 300 GHz, ultra high frequency to extra high frequency, where mostly we are using satellite communication, cellular mobile phones, satellite communication, radars, all these are applications. So wireless communication or transmission, again we are transmitting through either radio waves or microwaves or infrared waves. So radio waves are used for multicast communication, that is radio and television and paging systems. They can penetrate through walls, highly regulated, use omnidirectional antenna. So this is a omnidirectional antenna. It will transmit the signals in only single direction. Microwaves are used for unicast communication, mostly for cellular satellites. Okay, high frequency ranges cannot be penetrate the walls. For that we have to use directional antenna or point to point line of sight communication. So these are the unidirectional antenna, mostly we are using in our homes, dish antenna, horn antenna, all these like wavegates, all these are comes under unidirectional antenna. Infrared signals can be used for short range communication in a closed area using line of sight propagation. So wireless channels are subject to lot more errors than guided transmission media. So interference is one of the basic factors, so that SNR will be very low. So to increase the SNR, the transmission due to the broadcast nature of channel, we have to decrease the noise. So channel also subjected to fading and no coverage holds. So up to now we have covered different transmission media, that is guided transmission media and unguided transmission media. In the guided transmission we are covered twisted pair cable, then unshielded and shielded twisted pair cable, coaxial fiber cable, optical fiber cable. Then in the next one is unguided transmission media, where we are using wireless communication. So thank you for listening this session. So any doubts you can ask me.